Problem number 4. This is 14 points. That was a typo. Has a power drill, tightening a bolt, average friction force, number of turns, and we want to determine the power required to tighten in 3 seconds. So we've dealt this whole module with angular motion, and one of the equations we had for power was it is equal to torque times omega. Okay, so that's the first important thing to see, is have an equation that will get us to our final answer. We don't have a value for torque, and we don't have a value for angular velocity yet, so let's see if we can determine how to find those. We have an equation for torque. Okay, it's force times some sort of distance. In this case, we're turning a bolt, and we're given some sort of angular friction force, and we're given the diameter of the bolt. Okay, so that friction force is opposing the turning, and you could think of its perpendicular distance as the radius of the bolt. So just to explain a little bit here, that's not really a good bolt. Let's redo this. Let's draw our bolt just as a that's a little better. Okay, so if we're turning it this way, there will be a friction force this way. Okay, and then the radius of the bolt is where we would calculate or use that average friction force. Alright, so we've worked some similar problems like that. Hopefully you understand that. Alright, so we're going to use the average friction force of 14 newtons. Okay, this is distance right here, not diameter. So we'll take our diameter of 0.85 centimeters, divide by 2 to get a radius, and we'll also convert to meters. Okay, we always want to work when torque, especially when we're going to get to power units of Newton meters. Okay, so if we plug that into the calculator, we shall get calculator going here. There we go. Alright, 14 times 0.85 divided by 2 divided by 100. Okay, so that comes out to be 0.0595 Newton meters. So that gets our torque. The omega, that's how fast it's being turned. So we're doing 12 turns or revolutions in 3 seconds. Okay, from the givens up above. 3 seconds, 12 turns or 12 revolutions. We'll go ahead and do the conversion of 1 revolution. It's 2 pi radians, because we always want to work with omega in radians per second. Okay, so that's going to give us a number of 12 divided by 3 times 2 times pi. 25.13 radians per second. Alright, so we can come back over here and we can use 0.0595 Newton meters times 25.13 radians per second. Okay, radians, remember, are unitless when combined with other things. We'll have Newton meters per second. A Newton meter is a joule, and a joule per second is a watt. So that is a unit of power. Joules per second are watts. So let's see, that number comes out to be 25.13, about 1.5 joules per second, or 1.5 watts. Okay. Key points here was to identify an equation for power, determine how to calculate those individual components, the torque and the angular velocity, and then make sure our units work out correctly.